Hello everyone, today we will look at some problems about homework 4. For the first problem, we need to determine that the gate is stable or unstable. Actually, we need to find the location of the center of pressure, the CP point, on the gate. And this is a rectangular gate, and we will also know the elevation of the water is 8 meters, and this angle is 45 degrees. So we can determine the height of the rectangular gate h. So the h should be equal to 8 meters divided by the sine 45 degrees. So this value should be equal to 11.31 meters. And for this problem, the pressure distribution should like this. And we also know the gate is a rectangular gate. So we know that the YCP should be equal to the 2/3 times the H along the gate from water surface. Professor Diplos had derived these equations in class. You can find these equations on the example 2 from the lecture number 5 notes in cross-site. And we know the H. So now we can find the YCP should be equal to 2/3 times 11.31 meters. So YCP should be equal to the 7.54 meters. And we know the distance from A to B is 3.5 meters. So we can determine that the YB should be equal to 11.31 meters minus 3.5 meters. So the YB should be equal to the 7.81 meters along the gate from water surface. So we know that the YB greater than the YCP, so the gate is unstable. We finished this problem. For the second problem, we need to find the weight of the hydrometer. And since this is a stable system, so by-unit force, FB should be equal to the weight of hydrometer. And we also know the FB should be equal to the gamma water times volume D. The volume D is part of the body volume that's submerged. So for this problem, the volume D should be equal to the volume of ball plus the volume of submerged stem. So the volume D should be equal to the volume of ball plus the volume of submerged stem. And from the problem, we know the volume ball is 1 cubic centimeters and the volume submerged stand should be equal to A times Z, and we know the A is 0.1 square centimeters and the Z is 4.7 centimeters. So we can determine that the volume of submerged stand should be equal to 0.47 cubic centimeters. So now we can determine that the volume D should be equal to 1 cubic centimeters plus the 0.47 cubic centimeters. So the volume D is 1.47 cubic centimeters. And we also know the water temperature is 15 degrees Celsius. So from the appendix table 5 in your textbook, we can find that when the water temperature is 15 degrees Celsius, we can find that the gamma water should be equal to the 9,800 newtons per cubic meters. So now we can determine that the weight of the hydrometer equals FB equals the gamma W times the volume D, so equals 9,800 Newton per cubic meters times 1.47 cubic centimeters times 10 to the negative 6 cubic meters over the cubic centimeters. So we can determine that the weight should be equal to 0.0144 Newton. So we finished this problem. For the third problem, we need to classify the type of flow. From the problem, we know the flow rate is decreasing with time. So we know this flow is a steady flow. And from this figure, we know the streamlines are not parallel. So the flow is non-uniform flow. So this flow is B, unsteady flow, and D, non-uniform flow. So we finished this problem. For the last problem, we also need to classify the type of flow. The A, water flow over the crest of a long spillway of a dam. We know over the crest, the velocity should be a function of two special parameters. So A, the flow should be the two-dimensional flow. For the B, the flow in a straight horizontal pipe, we know the velocity only depends on the radius of the pipe. So the B, the flow is one-dimensional flow. For C, the flow in a constant diameter pipeline that follows the contour of the ground in a hilly country. The velocity also only depends on the radius of the pipe, so it is a one-dimensional flow. For D, airflow from a slit in a plate at the end of a large rectangular duct. So the velocity depends on two special parameters in the rectangular duct. So it is two-dimensional flow. For the E, the airflow past an automobile. It is obviously that the flow is a three-dimensional flow, and the F also, the flow is a three-dimensional flow. For G, the water flow past a pipe that is like normal to the flow across the bottom of a wide rectangular channel. So the velocity depends on the two special parameters in the wide rectangular channel. So it is two-dimensional flow. So we have done this problem.